一首歌，和别人的不同。我不是美女，我也不是黄蓉。问世间情为何物，有多少人会懂？身边来来往往的人都太匆匆。我是一粒沙，自由飘荡在空中。我是一阵风，每天呼唤着黎明。姑娘也会有自己梦想的天空。世界这么大，总有爱我的英雄。黄飞鸿，红红红的小脸红彤彤。黄飞鸿，红红，眼神像会有朦胧。
IGES-Converted cutting with 5-axis cantilever roller. CMSCAPP provide 3-dimensional CAD system which provide IGS file converted into this system, and we can use 3-dimensional surface along boundary or 3-dimensional surface along face to do the tool pass for water jet cutting. The IGS file supports transformed from SolidWorks or UG or VSCAPP. First of all, have to use IGS-A to translate the IGS file into boundary sections, and then use IGS-B to convert the surface. If some surface negative positive mixed, we can use negative surface to let the positive surface become negative or negative surface become positive, or use change UV for some surface with some triangle polygon missing. After these procedures, we can use save surface direction to save in the data file. This moment, prepare for loading. Right now, I try to show load surface direction to load a prepared IGS file. In here, we can see a bpk3.sdr. Open the file. Take time. It will show on the screen. A small tube insert into a big tube. We try to get the circular intersections between these two tubes, and doing bevel cutting. That means incline the angle of the tool along path. If the tool vertical, it cannot welding or cutting, so we have to incline the angle to do the bevel cutting. The bevel cutting is the same important as 3D blade cutting. If the circular sections inside a surface only, then we can use the function 3D surface along boundary. Pick inner boundary. Then we can get the circular section immediately. But this moment, this circular section belongs to two surfaces. So we need to use editing functions to cut the circular half part and this half part and combine them as one circular sections before doing inclined angle pass. So right now, use 3D surface along boundary. As pick this button, the surface boundary, the pink words display on here. Then we can use the mouse cursor to put the cursor to pick the surface. The mouse positions, the boundary of the surface will be highlighted. So we pick this half first, the boundary highlight. Then press the right button of the mouse. It says this surface is surface number 3. We use normal direction to cut the boundary. Okay. 3D along boundary NC file output. You can see the data in here. K6 first. And then we save it. Save CC as test 1. And move to the tail. And renew to clean the data area. And do the next half one. Use 3-dimensional surface along boundary to put the cursor to see the highlight of the surface. And press the right button. This is surface 4. Use normal direction cutting. 3D boundary NC file output in here. Then we save CC file as test 2. Then for easy looking, we renew the screen and use scene to reload the geometry of the cantilever rubber. We do the editing one section and the other section. We load CC test 1 first. The shape like this. The started point is here. This root is what we want. We have to remove the rest of it. First of all, we have to use next record to see how the root goes. You can see started from this point and then go this way. For fast move, next page. Right now it's 132. We have to move to the rear of the circular half. In here, a function added line number. Right now it's 132. Suppose we change to 232. If you jump to here. For faster, we say 432 and more 932 to the end. So 542 to here. Enlarge. Move next page. Approaching the end. You can see the data 663, the same as 664. This is the way the system does. So at this point, we press next record, and the next record, the same. Next record, and next record, the same. This is already outside the end of the half circle. A half line in here, a half line in here. The left half will go one step forward. This is one step to next. So we have to move back. We have pick the left half. Until this point. This go one step up, go down one. Okay. The rest of these points we have to remove. We use delete after to remove the rest. Only 660. In here. We go back to the head tail. Put on the left half of the button to go to the first line. And change the viewport. The point right now in here. We go next. Okay. This is what we want. We move one more to cut from here to the end. The half circle is created. So we use save after to create a file, a CC file. We use test1, test2 already. So we name it as test3. Okay. And renew it. This half finished. And we commence to next half. After renew, we load CC file test2. This one This one is what we need. We have to remove the rest of it. The start point is here because the last roots will stop here. We will connect to the first point of this root. And go the rest until the end in here. So this is correct. And we see next page how it works. The point is here. So he go here and here to here. So we know we have to go to the end of the circular half and to remove it. And then go back to the beginning of the half circle and to save the rest to get the another half. So we go next page. Right now in here, we learn already just edit line numbers. Suppose 509. Come here faster. And 609. Come here. Right now, 679, approaching the end of the half circle. We enlarge the window. Use next record step by step. Okay, this is the position, which is the end of the half circle. Move one forward, another one, and the back one, and remove the rest. How to remove the rest? Use delete after. You can see the cursor position is 682. Remove the rest is from 683 to the end. All will be removed. Delete after. Okay, only 681 are here. Right now, find the beginning of the half circle. Use line number. Suppose 281 in here. '81. In here. Enlarge it. And then go step by step backward. Use the half of next record. One by one. Press the twice to go one step backward. Okay, this is the beginning of the half circle, what we need. So we save after from this point, save to the end, save after. We save it as test 4. We use test 1, test 2, test 3 already. We save test 4. Okay, go. Then test 3 and test 4 are available. We have to Uliang these two lights. How to do it? We just renew the data area and load test 3 first. You can see the first point, test 3, is K8. For water jet cutting, we have to use K6. Right now, it's in the first line. We use modify to change the K data from 8 to 6. Okay. Then it is changed. And to see the end, 639 is K8, because we have to continue the next half. So K8 is continue line. It's okay. We don't have to change to K10. The K10 is only cross the sand and cross the water, which is used at the very end of the route. So we move to this point and use one function to put fire started from this point. To put what fire? To put the next half, test 4. You can see we will continue from the end of the last test 3 fire until to see the head or tail to 1279 to the finished. The last one is K8. We have to change to K10 to cross the water, to cross the sand. Right now, stopped in at 1279. We just use modify to change the data type K8 into K10, which is changed. A circular intersections has been shown, but we can see 1277, 1278, the data are the same. So for each point has 2 same coordinate. How can we remove one? Right now it's 1279. And the TCP point stopped at head points. Then we can use upside down, and then another upside down, go back, press twice. The first one upside down, the system will go the converse direction. Another upside down will go back to the same direction, and use head or tail to see the tail. You can see half duplicate points being removed. Right now the total point is 660 points, and you can run to see how it goes. The same directions. Okay. Then how can we do the inclined cutting? First of all, we have to save this CC file as test 5 and renew the data area and reload test file. You see nothing changed in between, but the system need this procedure to let every data clean. Then use can pass. The can parameter is 1, and then use 2D inclined angle pass. Inclined angle you can put whatever, 20, 30, 40. Right now suppose it's 30-degree inclined angle to do the bevel cutting. Okay. Before go, we cancel it first because we didn't do renew. Okay, we move to here and renew the data. Then we do the inclined angle purely and choose inclined angle degree of 30 degrees. Okay, you can see the data available in here. It started from these points, KA, and inclined insert, and K6, open water, open sand in here, and inclined cutting a long pass until the end. What's the end? (2971) is this point. 2972 is this point. We will retract inclined to these points and stop the program. Right now, the CC pass finished. We can save the CC as test 6 and then remove the data. Before the programming, we have prepared a S file. The IGS file, we use polytrans to translate it as a S file. So we reload S file, bppk3.x file, and to see the file like this. And load the CC, test 6, the toolpath, the data available here, and we use move to the first line, inclined at the top. The second line will incline insert into the started position, and then incline cutting the rest. Okay, let's go to see how it works. Just run. You can see the cutting. Okay, the speech is not finished. Someone have seen already in here. The tooltip seems a little inner. The small tube is not exactly along the intersection circulation. This is what we cannot stop the speech. This is a very big disadvantage of the system called Panasonic kernel system. Panasonic kernel system is very, very famous in the world. Belong to Siemens Corporation. Some very important, very famous CAD system all use Panasonic kernel to create their CAD system. Suppose like UG, like POE, SolidWorks, HCAD, VCAD, etc. There are 6 surfaces created by IGS transform. One surface named conic section or conic surface is the weak point of Panasonic kernel system. a sphere, a cylinder is all belong to conic surface. At the very beginning, the CAD system doing the conic surface by means of geometric way to create the model. The new method is always use non-rational B-spline surface. Short name is NURBS, NURBS curve, NURBS surface. So today, every people thought the IGS converted out the conic surface must be conic, must use NURBS parameter to create the IGS output. The rest 5 surface, everything is parameter output already. Only conic surface. The Panasonic kernel used the very old method, which is the geometric output. This Achilles heel damaged plenty of research company, research bureau. Last 30 years in Taiwan, our government doing the research try to avoid CAD system, direct into CAD system by means of IGS file converted. This is what I am talking to. I'm taught to work as well. One is M-CAN, another is E-CAN. Spent at least 20 years develop all fail. At that moment, nobody knows why get fail. Why two surfaces are not in the same boundary. That means something lost, some surface loss in between. Lately, our company found very interesting. Happened in Panasonic kernel is simply because conic surface is not correct, or we can say we misunderstand the output of IGES file. We use the wrong way to do the clipping of the surface. The clipping boundary is not NURBS, but we use NURBS to do it. That's the reason why a big gap happened in between. I show an example in here. This is very simple one. This is a circular surface is a conic surface, and runoff surface at the boundary. This part is provided by my customer. You can see the surface at here has a very big gap in between. The circular surface should extend to here, but his shrinkage to these points. And in here, a gap as well. But if we don't use NURBS boundary clipping the surface, we use geometry boundary solution. How it works. And we go back to see the demonstrations shown by our CAD system CMS, which use geometric solution. This is a top surface, circular surface. We highlight, use the yellow lights, and this is round off surface. Highlight with red lights. You can see the joint boundary precisely without any gap. Why CMS does so well? Because we found the IGS output of conic surface. The trimming data is not NURBS around this boundary. It's a geometric curve around the boundary. Then the surface trimming is correct. This is no way to save Panasonic corner, because it works for so many decades already, and no researcher available this moment. The only thing we can do is avoid to use conic surface, or not use IGES file converted, direct to use a step file. This problem can be avoided. Okay, to the end.
我的爱都是为你准备的，我的心都是被你陶醉的。